Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
This begins Module 3, Graphing. Yesterday we set up an experiment to find out if there was a relationship between the number of wines and the distance the air trolley will move. Today we will analyze the data each of you collected and prepare a line graph to show the relationship between the number of wines and the distance that trolley traveled. Two-coordinate graphing is an essential skill for displaying data collected during science experimentation. In order to complete a graph, you must remember to include these 6 items: a title, label the x-axis, label the y-axis, include all units in each of the labels. You must label an independent variable, and you also must label a dependent variable. First, let's review an important term that will help each of you better understand graphs and graphing: variables. Variables are factors that can change in experiments. In our number of wines versus distance experiment, 2 variables were used. One was the number of wines each air trolley propeller was given, and 2, the distance traveled by each air trolley. A two-coordinate graph has 2 axes. The horizontal or side-to-side axis is called the x-axis, and the vertical or up or down axis is called the y-axis. It is important to remember these 2 terms, the x and the y-axis. Both of these axes must be given a label. In order to label each axis, you must first identify the independent and dependent variables. Now the issue is, how do we do this? You must first ask yourself, what did I know before the experiment? For example, before we began the air trolley flight experiment, what variable did you have control over? That's right, we controlled how many wines were given to the air trolley propeller. Therefore, the independent variable is the number of wines on the rubber band and is labeled on the x-axis. Please remember, the independent variable is the variable you have control over. Now we must label the y-axis. But again, you must ask yourself a question. What did I measure in this experiment? You measured how far the air trolley traveled, or the distance the air trolley traveled. The distance the air trolley traveled depended on how many wines you gave to the propeller. This makes the distance the air trolley traveled the dependent variable. It is important to remember that the dependent variable is the measured variable of the experiment. Take a quick look at this graph and be sure that you labeled the information for the y-axis appropriately. Let's review independent versus dependent variables, and be sure this is all in your notes. Independent variable is the variable you control and is always labeled on the x-axis. The dependent variable is the measurable variable and is always labeled on the y-axis. All labels must include units. So all labels must include units. It is important to remember the x and y axes are number lines and must be labeled. Numbers are assigned to each of the lines starting with 0 at the origin, which is where the 2 axes meet. Be sure to remember the origin is where the x and y axes meet. So the origin is where the x and the y axes meet. It may not be possible to number the lines one by one. You might have to count by 2s, 5s, or 10s, depending on how that fits your data. So take a look at the data you have collected and begin to figure out how to best number your axes. You need to know it is important to use as much of the graphing space as possible. For the experimental data collected, you will probably want to number the x-axis by 10s, starting with 0, 10, 20, 30, and so on, because you have 10 units on the x-axis and need to reach 90 lines. Look at the y-axis. You also have 10 units to work with, and so you can number those lines by 100s to ensure we reach the 900 centimeter mark. At this time, be sure you have labeled the axes of your graph. In this experiment, the x-axis is labeled number of lines and the y-axis is labeled distance. Note that when appropriate, units must be included in the label. Thus, centimeters were in parentheses there. Now the graph must be given an appropriate title. The title is usually stated as an x versus y, often followed by a descriptive phrase. The title for our graph will be called number of lines versus distance. Next, you must plot the ordered pairs. Refer to the collected data there and begin plotting each data point. Next, plot the ordered pairs. Refer to the collected data and begin plotting each point on the graph. First, find the number of lines on the x-axis and move up until you reach the distance on the y-axis and plot your point. Once all plot points are made, you will then draw a straight line that passes through or near as many of the data points as possible. This line is called the line of best fit. You should know that the best fit line shows the relationship between the two variables. Understand the best fit line is a predictor of future events. Therefore, if a number of lines is known, the distance can be predicted. This is helpful to know when making scientific predictions. Let's review our graphing checklist one more time. If you haven't already written this down, please write it down now. Each time you prepare a graph, you must include a title, label the x-axis, label the y-axis, label the independent variable, label the dependent variable, and be sure to include all units. Each worksheet we use will include this checklist for you to use, and you should always remember to include all 6 of these items. This concludes our introduction to graphing.